All right, so I think this is recording. Let's take a look here at this quadratic inequality. I like to have my variables on the left-hand side, and for inequalities, doesn't really matter, I guess. If the arrow is pointing towards 0, it's still pointing towards 0. Now, I also like to have my leading coefficient be positive, so I'm going to multiply everything by -1. And that'll change the direction of my inequality. All right, so I look and see that I am comparing it against 0. I have no greatest common factor, so I'm going to factor this on the left-hand side. I have a leading coefficient that is larger than 1. So the x method is nice when you have the leading coefficient different than 1. At the bottom of the x, I put my middle term. At the top of the x, I have the first times the last. So now I look for two values that when multiplied together give me the top expression, but when added give me the bottom. -4x and +1x will do the trick. And I want to make a table now. Because that leading coefficient is not 1, I can't come in and use that -4 and +1 directly. All right, so again, I use the first and the last along one diagonal. And the two values that I found for my x along the other diagonal, it doesn't matter where I put the -4x, whether I put it here or here. All right, so now I factor this both horizontally and vertically. I see that -2 is a common factor between these two terms, and that these two terms are prime, so it's just 1. Here I see that they're both even and both have an x, and these both have an x. So I've got 2x plus 1 and x minus 2 as my factors. I know that now if I set these equal to 0 and solve, I'm going to find my critical points. For my number line, I'm going to use these critical points to divide the number line into 3 regions. I'm going to label these regions A, B, and C. Excuse me. Now I'm going to determine whether to shade or not to shade these critical points. And since my original inequality is a strict inequality, I'm going to leave those hollow. So I'm going to come over here and make a table. The first column of my table, I'm just going to label it a test point. My middle column, I'm just going to copy the expression that I have in factored form. And the last column of my table, I'm going to call it my truth column. So in my region A, I'm going to pick a test point, a number that is smaller than -1/2. I'm going to pick -1. That's easy to do arithmetic on. If I replace x with -1, I get -2. -2 plus 1 is a -1. -1 minus 2 is a -3. Negative times negative is positive, and a positive number is not less than 0. That's a false statement, so I'm not going to shade any point in region A. Since in region B I go from negative points to positive points, I'm going to pick 0 as my test point. It's easy to do arithmetic on 0. 2 times 0 is 0, and 0 plus 1 is 1. 0 minus 2 is -2. 1 times -2 is -2, and that is a true statement that it's less than 0. So I'm going to shade in, include all the points in region B in my solution set. Now in region C, I'll go ahead and pick 3 as a test point because that's larger than 2. 2 times 3 is 6, and 6 plus 1 is 7. 3 minus 2 is 1. 7 times 1 is 7, but 7 is not less than 0. That's a false statement. I'm not going to include any of these points in my solution set, so I'm only going to shade in this region B. So now I want to describe that I have a picture of my solution set, and I want to describe it using inequalities. I've got negative 1/2 is less than x, which is less than 2, and that's my final answer. Don't be afraid to ask questions, and I will talk to you later. Bye.